Welcome to the Phoenix era. This is going to be a talk about hot storage on Filecoin. You've already heard a little bit about hot storage on Filecoin. I don't know if anyone stopped to really talk about what it is or what we're trying to build on the Filecoin network. But yeah, this is what we're going to be doing today. Is we're going to talk a little bit about the history of Filecoin. Kind of some of the various previous eras that Filecoin has had, and how we got to where we are today. We're going to talk a little bit about what hot storage is and how it will impact Filecoin as a network, how it will change, in my view, fundamentally change the nature of what Filecoin is. And then I'm going to talk a little bit about how we get there. Some of this is going to cover the things that we spoke about, that were spoken about in the last couple of talks, about different new features that are in the network, but also just kind of giving you a kind of holistic overview of everything that's needed to deliver really effective hot storage on Filecoin. And then finally, we're going to end with a little sneak preview of a hot storage product that myself and a couple other folks are trying to build on top of Filecoin right this very second. So, all right, here we go. Now we're getting to, oh no, we have one more filler slide. I have to tell you a little bit about myself. So I'm Hannah. I've been in this network for probably too long. I started working on IPFS. Later, I got moved to the Filecoin team, was part of the Filecoin mainnet launch, and worked on some retrieval stuff in the network. I also, some of you guys might have used a tool called Lassie. That was a team that I led to try to make retrieval a little bit easier. We made some progress. Still, I would say Filecoin retrieval still work in progress. And now I'm I put the CTO title in front of myself, which is the first time I've been bold enough to pretend to be a CTO. I'm working at a company called Sriracha, and I'm going to be telling you guys a little bit about Sriracha later. So, oh yes, and then lastly, this is where my joy comes from in life. Not blockchains or decentralized storage, but my wonderful partner and our wonderful four-legged daughter. Cool. All right, now we're done with the filler slides, I think. So I want to begin with a history of the world of Filecoin, part one. Cool. So the first era of Filecoin was the vaporware era. This covers the period of about 2017 to 2018. I think there's a couple folks in the room who might have been around for that. Filecoin had a massive token raise, probably the largest in the history of token raises, I think, to this date. No, okay, never mind. Some of the folks who even predate the vaporware era confirm that there are other options. We were trying to build Filecoin. There was a lot of sort of like experimentation, like no one quite knew what we were trying to build or how we were going to do it. There was a lot of work going on something called Go Filecoin, which was the original implementation of Filecoin. Anyone know what that is called today? Venus, yes. That actually, Venus evolved from this original code base. There were at the time, I would say that things were ambitious. The first Protocol Labs summit I ever went to, the most of the talk was about how we were going to get to Mars, which I was coming from an agile software consultancy, and that seemed like not an agile way to do things, to start with interplanetary exploration. But yeah, it was ambitious. There was no chain. There was nothing real. But I think that there was a major shift into this period of super high focus and productivity that began around towards the end of 2019 and then continued all the way right through the middle of a pandemic to the Filecoin mainnet launch in October of 2020. This is when Lotus emerges as a functional implementation in Filecoin. This is when we get to the mainnet launch. At the time when I was here, a lot of people were just putting in crazy hours, very classic startup launch type process. And there was a reward for it. We launched mainnet. It was amazing. And we got rewarded fairly handsomely because our token price went way up for a second. I call this the Bacchanal era because it was like, the height of a big old party because suddenly it seemed like there was an infinite supply of capital, which is an amazing thing to be a part of. I think it led to a little bit of like, what if instead of we were building Filecoin, we just did everything in the world? We could be redoing how government works, like very, very broad scope. I will say, by the way, this part might be a tiny bit spicy. I got to be careful. But there was a little bit of like corporatization, I would say, going on during this period because particularly Protocol Labs, which was the core builder of Filecoin at the time, grew rapidly, and as a result, there was a big change in culture from people who just wanted to build a product to people who, and there's nothing wrong with this, people were thinking about like, how do I have a regular job and support my family and get promoted, and like these are good things, but also there was like a shift towards just people being interested in individual advancement, I would say. And one thing I don't love about this era is I think real core gaps in functionality were left largely unaddressed. When Filecoin launched, we had POREP, and it's a foundation for building a storage product, but it's not the complete story of building a storage product. And unfortunately, I think during this time, we didn't really address those core gaps. That led to the end of an era, which is 2023. We had a little bit of a macroeconomic downturn, a little bit of a crypto crash. And it's around this time where we started to realize that a lot of the Filecoin tokenomics had some challenges in them. Tokenomics are some, I think we're going to eventually conclude that there's about as predictable as like macroeconomics, because like I was around for the design of the Filecoin tokenomics. They were way more intentional than any other like token design ever, and there were still major mistakes that we just couldn't have predicted. Also, but one of the things that I think starts to really emerge in this era is that the like gaps that have been left unaddressed start to be noticed, right? People are wondering, more and more people are saying, when is File going to do the thing it's supposed to do and give me easy, retrievable, decentralized storage? And it's sort of a little bit of a frustration building. And, and obviously it's a bit of a downturn time. And that's sort of led to this year, which I think has been a really interesting year, where the nature of the Filecoin community has changed a lot. The vast majority of core software development on Filecoin was happening inside of Protocol Labs up until this year. And that is no longer the case. We have the emergence of a group of small, a small number of small teams that are working independently and trying to focus on something that really matters to them, that they can deliver really, really well. And I think that that's actually super awesome. Because you have all these small teams that are operating independently, they are all increasingly aware of how am I delivering value to the network, right? It's not okay to just sort of like iterate indefinitely without shipping something that delivers value, that makes a viable business. Even when the groups are not for-profit groups, they still are needing to justify their own existence by doing things that are actually valuable. And I think it's going to be, it's a really, my hope is that this is the beginning of the next era, which is a major resurgence. I call it the Phoenix era. And I think it comes from mature, usable hot storage on Filecoin for all, where Filecoin becomes essentially the data layer for all of Web3. And fortunately, that's something that is really, really needed. The Web3 is increasingly generating more and more data and looking for places to put their data. And Filecoin has always been probably the best thing in town for that, but we're going to be the thing that can. But if we have mature, usable hot storage, we will be the only game in town for that. And I think that you're going to start to see optimizations in the way that storage provider operations work and the network works, that and an increased value leading to a different kind of, hopefully another second Bacchanal era, but this one driven by actual profitable business economics, as opposed to token markets having a great bull run. So I'm really excited, and I want to tell you exactly how we're going to get there. But first, I want to talk about hot storage. What we've said, I think I walked in and I heard it said 10 times, and now I'm talking about it. And I want to say, I want to define what it means and why it matters. So, hot storage is simple, fast, reliable storage and retrieval of any data of any size for any length of time. That's what it means. What do we mean by it? And now I'm going to go a little deeper on each part of this. So what do we mean by simple? I should be able to store data on Filecoin without knowing anything about those words up there or any other set of words that relate to our IPFS stack in terms of like knowing how our data is encoded. I have data. I want it on Filecoin. I want to put it on Filecoin. I don't want to know anything else. I would argue that in most cases, I should not have to find a storage provider. That shouldn't be my job. Because the reality is that finding a storage provider is a very manual and very time-consuming process for the average data consumer. And no one ever thinks, like, I think we've never, like, we had this idea of Filecoin as a marketplace, and we've built it as a network where you can choose between lots of providers, but you don't get to use a marketplace in the sense of, I have data, I want it stored, I'm just going to be matched with the right person to store my data. That's what I think is the ideal form of how storing data should work. I want to be able to pay however I want, and that includes in fiat. I mean, the reality is that people, a lot of folks do not want to pay in crypto. A lot of folks have to pay in crypto and really want to pay in crypto. We should be able to support both. And it shouldn't, one shouldn't be like the better way of doing it. Ideally, so we need minimal software overhead for the data client. Now, this doesn't mean the data client can't run software. They should they may need software to interact with our network. That's totally fine. It shouldn't be software that requires special hardware. I should be able to run whatever software I need to put data on Filecoin, and I shouldn't be like thinking about, is this going to kill my computer to run it, right? Ideally, and lastly, I think the most valuable simple form of hot storage is hot storage you can program from smart contracts or other software. Right? The reality is possibly the majority of data storage happens on the internet, not by someone, doing the Dropbox thing of dragging and dropping a thing, but rather by code executing within another program to put data onto the internet. So it should be programmable storage, and especially since we are in Web3, it should be programmable from smart contracts. Okay, what do we mean by fast? So, probably one of the biggest things about fast that a lot of people don't think about is read on write. Does anyone know what read on write means? Okay, I'm seeing people nodding. I'll just, basically it means when I put data onto Filecoin, I should be able to immediately retrieve that data, not after a 2-day po-rep, situation. Probably we're looking at minimum less than a second latency for retrievals. And that's not all we mean when we say fast retrieval. Fast retrieval means that you need to be able to get it within less than a second, no matter how many times you request it, or at least up to some reasonable number, right? Because like one of the things that we've experienced on Filecoin in a number of cases is folks who offer less than sub-second retrievals as long as not more than 1 or 2 people ask for it at once, right? And that's something we have to solve for. I think personally, we should be using standard web protocols for retrievals. It's nice to support and be interoperable with, Bitswap and whatnot if you can. But I think the bread and butter is in standard web protocols, and I would go even farther with this. My view, if you look at how hot storage happens on the internet in terms of Web 2 products, the way you retrieve data if you're using like an object storage paradigm, you put bytes on the internet and you can read bytes from the internet. And when you read the bytes, you can read a range of bytes, but that's it. You don't have some fancy query based on, IPLD or whatnot. You essentially, a storage provider is someone who puts a hard drive on the internet, and you have a bunch of keys that can be used to look up bytes and byte ranges within the net. And that's about it. So I would argue that's a good model for how we should be thinking about retrieval, for at least for the concept of the storage provider. I will talk later about how you should still be able to support pretty complex queries, but I'll get there in a minute. What about reliable? Well, so there's actually I just have two really key statistics here that you can use to think about what does reliability mean. So there's two things. One is availability. Availability means when I go to try to retrieve something, I am successful in retrieving it. This is actually the harder one to hit, a really, crazy high SLA on. I use 99.9% availability. And the reason I use that is that's Amazon S3's SLA for availability. When I try to go to retrieve it, I should be able to get it. Now, that means that what that comes out to is that's actually not as little as you might think. That means in a year, you can be down for, it's like half a day. No, it's not half a day, like 8 hours, right? If you're going SLA by the year, they're usually done by the month, so you're a little bit tighter. The much higher one is durability. Durability just means my data isn't going to be permanently lost, right? And durability, we should be able to hit lots and lots of nines on. And in fact, we already have that capability through POREP, right? POREP is literally designed for durability guarantees. Cool. So that's reliability. And I'll talk a little bit about how the proofs that we've been talking about this morning feed into these two statistics. Flexible. What does flexible mean? I'm tired of we're storing car files, we're storing UnixFS, we're storing IPLD. You should just be able to store bytes. And if you store bytes and they're in some more complicated encoding, you should be able to store that encoding so that someone can read it in a more interesting way. But there's no reason to force the people who are putting hard drives on the internet to understand data in a super structured and complex way. No one else on the internet does that. Any size. Obviously, this is where we need to move beyond the parameters of a typical Filecoin storage deal, right? You need to let people store anything from a very small thing like an image, maybe 1 megabyte, to things that are very large and go beyond what we currently have as our sector size, right? Probably any length of time. Most people pay for storage. They don't even have a definitive time. They just sign up and say, I'm going to pay every month. And if I stop paying, then I'll stop having storage, right? So that's flexible. Those are the properties of hot storage. Why would we do all the work to unlock all of this, right? So my argument is that there's an exponential utility increase that opens new markets and unlocks massive growth, right? So what do we mean by exponential utility? Look, this is the original promise of Filecoin. If you go back, if you get real about it, what we told everyone is that we were going to offer this Airbnb for storage, right? Which is a little bit of a weird metaphor, but I'm going to be able to just rent someone's storage and it's going to operate just like I would on a cloud like AWS or Google or Azure. But I'm gonna have to. But I'm not going to be paying someone fancy. I'm going to be paying whoever's got stuff available and can do a good job, right? That was our promise. So for one, we're just doing the thing we said we would. Second, we have resources on the Filecoin network, right? The amazing thing about POREP is that it has put all of these hard drives into the Filecoin network, right? We have experience working with data storage and we have all these resources. So why not put them to maximum use, right? That's another way another thing that unlocks with hot storage. Look, the thing is, cold storage is actually a legitimate market, right? It's a sizable the reality is that, backup of enterprise data is something that, is, I can't remember, somebody gave me some number of billions of dollars in that market. The challenge is that it's a commoditized market. It's kind of boring in the sense that, like, who wants to say, like, oh, look, you just can't get too many people excited about, like, oh yeah, I totally am storing like AT&T's call logs for the last, 10 years. Isn't that amazing? Actually, it's probably really useful. Honestly, one of the more annoying things about Filecoin is that we do way too many things that are just useful and aren't very hypey. Like, we stored all of CERN's data, just held humanity's treasure in physics for the next 10 years. No one cared. But then we put Solana on our chain and everyone was pumped. Cold storage, it only serves some. But the thing that I think is interesting about hot storage is that it applies to a much greater number of people. Now, that doesn't mean that it's as much data, but like it's all the people who just want to put one thing on the internet. And that's a lot of people, which creates a lot of buzz and a lot of interest and a lot of utility. So what are some of the new markets we could be unlocking? Right. I've said this before, Web3 is starting to generate data at scale and needs a place to put it. Generally, they want hot storage. Right? There is chain archiving. We're already well set up to do that, but there's a lot of things, a lot of parts of Web3. What is it? DPIN? I still cannot. I don't really understand what DPIN is, but don't tell anyone that. There's like data availability is a whole other thing that people need. They need to be able to access their L2 data that's being generated. You've got like, they're starting to, you have all of these chains that have built the ability to compute at scale finally. And obviously data is an artifact of compute and they need it. Obviously AI is in the mix. Segments, there are also like just segments that are not served well by centralized storage. Like this is where some of our unique data structures come into play that are really valuable, right? So like Web3 gaming, right, is it's not served well by centralized storages. Services, there's things you can't do in a centralized service, like have people send NFTs directly to each other of different assets in the game. There's also the ability to distribute like big pieces of data like game patches using IPLD to make the patch much smaller than it would be without. So there's a lot in content addressing to make it much smaller than it would be without that ability. So DPIN, AI, others emerging, massive needs, maybe eventually some compute over data. I do not doubt the tech industry's ability to generate new things that need more data storage. So yeah. There's an interesting thing here is like, where are we jumping in, right? How is our offering useful? I think there's a couple of different ways to go here. You can certainly compete on cost if you want to. It's pretty hard. I think that probably if you're going to compete on cost, you're going to have to be very, very conscious of like everything you do and how you're going to actually be cheaper than centralized storage, because the magic pot of crypto money in the sky is only so much, it can only lower the price so much. In reality, ultimately, you're just practicing inflation. So, like it's useful, but not the only tool. And it's hard to compete on cost in decentralization. You think it's going to be cheaper, but often it's sufficiently high overhead that you can't do it. The other place, though, you can definitely compete on is features, right? The reality is that Web 2 isn't really usable from the Web3 world, right? You can't run things from smart contracts. You're not creating data in ways that can be reliably referenced in the ways that people on Web3 expect. Like you cannot put an NFT into S3 and have a nice IPFS URL, which is what people expect, right, in Web3. So you've got a lot of options on features, and the reality is you're hitting, like, this is coming at exactly the right time where people are just super skeptical of the giant data silos we've been putting all of our data into, possibly more than at any point earlier in the entire history of computing. And I think you're going to unlock massive growth, right? The thing is, I think that people want to use decentralized storage. I don't actually think this is a hard sell. The primary blocker is ease of use, right? And right now, in the hot storage I'm describing is infinitely easier to use than the current setup with Filecoin. The reality is we actually have a rep for being nerds, and that's kind of cool. Like, people think that we're a bunch of research brainiacs over here in the Filecoin world, which is both an annoying rep and also like useful because people trust us that we're not going to scam them, that we're going to deliver a good product because we are desperate to, be proven the smartest kids on the block or whatever. And we just have a massive automatic lead, right? Because the size of our network is none of the other networks are anywhere in the neighborhood of Filecoin. So, now's the time to do it. So how do we do it? Part 3. Cool. Unlocking the Phoenix. I'm going to talk to you about the hot storage journey and everything that's needed at each stage of the hot storage journey. So I'm going to just walk through the different components of a successful hot storage solution and what's needed. So we have onboarding, how we get data into a hot storage network. Then we have hot copies, the things that actually, the versions of your data that are readable quickly. Cold backup, which is basically data, copies of your data you're not going to retrieve from frequently, but it's still useful as redundancy and insurance. Verification, this is where we get into some of these proofs we've been talking about. How do I know that the data that I put into a network is still there, still retrievable, and will be retrievable at the SLA I'm hoping for? Finally, we have the last 2 components that ultimately lead into getting the data back out, which are indexing and discovery is one. Basically, how do I find my data? How do I understand the data when I want to retrieve it? And retrieval, the actual process of getting data back. Cool, so I'm going to walk through each one of these in a little bit of detail. Onboarding has a few different components, right? You have to prepare the data somehow. Even if we should be able to take in raw bytes, but the reality is we are content address data at network. At minimum, we need to hash everything once. If nothing else, we probably are going to do some other things. Maybe we pack into a car file, the usual mumbo jumbo. This should all be happening without the user's understanding of any of these concepts, but it needs to be automated. Someone needs to do it. Probably, if you're going to offer something useful to the world, we need to start thinking about encryption and private data, right? The reality is the vast majority of people who put data on the internet are not thinking, I just want to share it with the world, including everyone. They want to share it with, the way I think of this, it's not like, I think the impulse is to think, oh, big enterprise sharing their trades, storing their trade secrets. But for me, it's like social, right? Most people want to share their data with their friends. And this has been proven to be a very powerful model for how data moves through the internet. So you're probably going to need some encryption, especially if you're going to deal with arbitrary sizes. You might need some sharding. Possibly, we might, as a network, need to look a little bit at erasure coding because it's pretty useful in terms of delivering fast and reliable retrieval later. I'm not going to go deep on that. And then you have aggregation. How do you get things into large piece aggregates that can be stored on storage providers on Filecoin, especially for the cold backup? And obviously this problem of provider selection. And this is actually a really complicated problem, and I hope there are more people thinking about it. I encourage you to get involved. I think there's a Phil Market protocol Slack channel on Filecoin Slack. If you're on Filecoin Slack, it's worth reading and getting connected to because this is a very unsolved problem. The group I'm working with has a solution. It's not the solution. I want to talk about some onboarding best practices because this is something that. Oh, sorry. Oh, wait, there's no way to go back. Okay, because this is something that the group I work with, Sriracha, I think we've kind of got down really well, and I think that we have some good ideas for how to do it, and I want to help you avoid common mistakes if you're one of our competitors, so you can actually compete with us. First of all, I don't think anyone should be calculating hashes on their own hardware on a server. The point at which our data becomes content addressed is a very critical point. That's the point at which you are moving from a trusted setup to a trustless setup. Sorry, I don't mean that in the blockchain sense, but the moment where you're moving from an environment of trust to an environment of trustlessness, the environment of trust should be your own computer as the client of our networks. So I think it's important that people provide tools to users to prepare their data on their own computers, but ideally those tools should not use lots of hardware resources. They should not take up they should not write additional copies to the client's computer. They should just do all of the data preparation and send it in already prepared. Another thing that I think this gets into is you should be generally thinking about, as you onboard data, moving it as few times as possible. On the way from a client's computer all the way to, say, a cold backup on Filecoin. Every time you move data, that's going to cost a lot of money, right? That's going to cost somebody money. You're going to either pay an egress or an ingress charge for whichever provider you're working with. It's slow, all these things. One of the biggest things that I think that I've learned along the way is that PodC is your friend, and PodC unlocks the idea that you shouldn't be rewriting piece aggregates over and over. You should only, in my opinion, the only person who should ever possess the actual raw assembled piece for an aggregate is the storage provider themselves, right? They should be able to pull all of the sub pieces from different providers and use the PodC proof to assemble the aggregate. And I think that that's a critical technique that everyone should be doing. In my view, look, I'm just going to say that, like, we need an ACL solution. We need a solution for access control. And I would simply propose that the best solution for our networks is UCANs. UCANs is a relatively new technology, but it's being increasingly adopted in our networks. I will say that I'm a particular fan of them, but the thing about UCANs are an access control primitive that is designed for a decentralized context. And that's really critical. And it's always surprising to me what people are talking about doing on, like, a storage provider operation. Like, you should never have a storage provider who has to manage a list of users who have access to data, right? Like, that should be managed by someone whose job it is to know who should have access to their data, which is usually the client, right? And you shouldn't be putting these tools on a storage provider. And the UCAN is a primitive from which you can do that. And I think we're probably going to need some markets protocol improvements to handle the deal making, particularly this matchmaking problem. Again, I keep hand waving and saying, get involved in that because it's freaking important and complicated. No one has great solutions. But we are going to need to be able to matchmake more effectively. Cool. Those are some onboarding best practices in my opinion. Let's talk about hot copies. Hot copies really just have a couple of key responsibilities in a hot storage platform. Hot copies need to meet the storage SLA, the fast part of hot storage. You got to be able to read on write through hot copies. You need to meet latency. You need to meet bandwidth. You need to meet HTTP. You need to offer HTTP range reads, right? This can be done by a Filecoin storage provider. Many storage providers have a hot copy. We call it the unsealed piece. And storage providers can actually serve as hot copies if they want to meet the SLAs required to serve hot data. It doesn't have to be a storage provider, though. It could be someone else. It could be an independent node provider of some sort. And finally, I would ask, is there really a difference, right? Does the word storage provider imply that I am specifically an L1 on Filecoin submitting POREPs? It could be it's anybody who wants to participate in a hot storage network. And it can be a Filecoin storage provider. It can be an independent node that maybe has less total storage but has really good bandwidth on their internet connection. These are the kind of, like, the types of specializations we could see going forward as we build hot storage. I don't think hot copies are enough. You actually want to use the thing that Filecoin does. Filecoin is really good at this. POREP allows you to do cold backup, so that you end up with, if I back up 3 times on Filecoin, I have 3 different copies of the data that are ultimately retrievable to the original data, and they're on different computers. And if one disappears, the other 2 are still there. Right? This is what Filecoin is actually the existing proof system is built to do. One thing that I think would be helpful in this is it would be nice if we could get some clear tools for unsealing that could be automated into like hot storage networks. And ideally, it'd be really, really awesome if the unsealing could be cut down to, I don't know, 30 minutes, an hour, something like that. I'll get to why, and I believe the next slide, verification. All right, this is basically my recipe for verification, right? You can hit the absurd number of 9s for durability through POREP. I mean, arguably unproven, but like the math is there. If you store 10 copies and they only go down one, each one has a 10% chance of going down, and you have 10 copies, you can get very quickly to lots of 9s, right? So I think that POREP is the solution for durability. What about the 99% availability? So this is where the proof of data possession is a critical piece of this, because the proof of data possession says the data is still there in a retrievable form, but it's probably not enough. You probably are going to need a retrieval testing program like Spark or maybe Retrieve. Okay, and that's the other part of 99.9% availability. And then the last bit that's not there, that I really wish were there, is if you actually do the calculation, right? Let's say that my hot copy does go down once a year. If it's going to take me 3 days to get that cold backup back to like the original form in the, if we have a POREP sealed copy and it's going to take 3 days to get back the original form, then that's going to leave us with, we're not going to have our 99.9% availability. So that's why I would really love to see the seal time come down just a wee bit. Indexing and discovery. We have a lot of tools here. And I want to put forward a couple ideas on here. So like there's IPNI, which is a working system for now. It works very well. It's run out of a couple people's basements, though, I think now, or maybe even not out of a basement anymore. It's a great way to find data. It's a global way to find data. It's not really designed for read on write. It's not designed for super fast retrieval and super fast latency. So you probably need to have a few other things in the mix with indexing. One thing that currently we do is, like on storage providers, we actually index car files so we know where blocks are in cars, right? So I call these things blob indexes, meaning like I have a giant blob of bytes. How do I find out where different important things are in that blob of bytes? In the case of a car file, it's where all the SIDs are. And then the other thing is you probably need some caching for indexing, right? Like the IPNI type layer is not going to be fast enough to find things, especially in a super fast retrieval context. You're probably going to want some caches, and IPNI will not provide you the complete index that you're probably going to need to do really fast retrievals, because you're going to IPNI will tell you this SID is available from this provider, but it won't tell you exactly where that SID is in, say, a large car file so that you can do a byte range request. A couple indexing best practices from people who've done it. So my basic line, like indexing should guide retrieval. Right? An index of a blob of data basically tells me how do I extract valuable things from this blob of data. And my view is that the best person to index a blob of data is the person who made that data, aka the client. And I would argue that we should take all of that stuff we do with Filecoin deals in, say, Boost, like we do like a DAG store, or now I think it's the Peace Directory. It's a giant. We ask storage providers to do this giant index of like all of the data that they take in, where they're just reading an unindexed piece and trying to find car files and try to make sense of it. Shouldn't be done that way, in my opinion. The person who makes the data should produce an index of data, and indexes are just storage. They're just more bytes. So you should be able to write a blob of bytes, and you should be able to write an index right after that and pay a little bit more to hold that index. And that simplifies the entire model of storage for storage providers. Also, indexes should not just be SIDs. We've got this, one of the things is because we've got this one format that we're so tied to with car files, we get in this habit of thinking that's the only way to index data. You can index data in so many different ways. You can index data in ways that are super meaningful and unlock amazing query potential, right? I can say, okay, this piece of this core node of data is here, but if you want to get this particular part of it, like maybe traversing an entire path down through a data structure, you can build an index of that. That's what a database does, right? And we could be doing that. Finally, you have retrieval. Retrieval is how you're going to get basically you're going to use your indexes and hot copy to deliver data to the user. Retrieval can come from a lot of places. You could have a CDN, you could have a client browser that actually just can read the public indexes and the public places where data is stored and reassemble responses. I think generally you want to support some of the gateway protocols at this layer, HTTP, the sort of pathing spec that we use on our gateways. But you could also do super awesome data specific queries and maybe some compute over data. Like the one I always come back to is like, we could store not only blockchain data on Filecoin, but we could store indexes that make it completely retrievable and queryable in ways that are super valuable. Okay, 2 more thoughts, and then I'm going to go on to my final section. I see I have 3 minutes left. I'm sorry for going over. Is this an L1 or an L2? It's probably neither. It's a mix, right? You're going to have both L2 network products, and you're going to need some L1 improvements in Filecoin. Finally, this is not going to be like the last iteration of Filecoin's mainnet launch, where it was like one small team working crazy hours. This is more of a family affair with a bunch of different players. Obviously, the Phil Oz team is critical because they're the folks who are going to be able best suited to deliver some of the core networking improvements that are required. You have a bunch of L2 networks in the mix. Storacha, Banyan, Basin, Lighthouse, etc. And then you also have the folks who are doing SP software, Curio. There's also like Web3 Mine, like people who are innovating in the actual process of operating a storage miner. Okay, last part, epilogue. Storacha. We're building this. Yeah. So I am part of a group or company that called Storacha. We are attempting to build everything I just talked about. And we're trying to build an awesome hot storage network for Filecoin. We already have one. We have a mature tool. We are building on the mature tools that have been used to build Web3 storage, right? So we are essentially starting from Web3 storage and evolving, which means that we're already starting from having 3 petabytes of data that we are managing, which is really a cool way to build things because you can't fuck it up in the way that you can when you just have an empty test bed that you can fuck around with. You have to actually serve users. It's really cool. We do all of our data prep client side. We do all our indexing client side. Soon, wow, did I put that on the today list that we do encryption client side? We might be doing that almost today. No, we'll be doing that tomorrow. We are UCAN based. We think this is the key way to unlock this, not just the kinds of user authorization you need, but also the kind of verifiable history of what's happened on the internet in the process of storing your data. We do already back up to Filecoin. We have a reliable backup Filecoin backup pipeline. It's been the result of lots of people doing lots of awesome work. We also have, also awesome systems like Spade, whatnot. We provide hot copies and indexing and retrieval on centralized infrastructure. Moving on. But we do that. Yeah, Storacha, so hot right now. I've been this is the entire purpose of being a CTO, is I've wanted to make this free. I love this meme, and I've wanted to make the Storacha version. Okay, cool. Coming soon, we will have hot copies that are not on centralized infrastructure. We will have incentivized retrievals. I think it's going to be super awesome to actually provide storage providers in the Filecoin network a way to be financially sustainable, because that's kind of been rough the last few years for some of them. We are going to be moving our coordination aspects onto an L2 chain at some point. And we are we're already offering ProRep, but we are going to be using PDP as a way of enabling us to put our hot copies somewhere other than centralized infrastructure. Long term, I would like to build a decentralized CDN layer for all this, but that's a pretty hard one. And I'm also running out of time. So yeah, Storacha and Filecoin. It's all one look. Essentially, yes, all of these things are Filecoin, and they will make it an awesome network in the future. Cool. Yay.